secret is the moment when everything happens. Contact is the answer, is the reason that everything happens. Contact. Let's make contact. 3, 2, 1, contact.
Earth, the watery planet.
It's a perfect morning, and the snow is all untracked, just waiting for us.
Robin, it's dawn.
That's right. And we're gonna be the first ones up on the slope, too.
What for?
We got all day.
Look, I don't know about you guys, but I like to ski on untracked snow. You know, before all the other skiers start messing it up and everything. You know, you're holding those wrong.
Oh, am I? Oh.
Is she? Well,
Are you sure you guys been skiing before?
well, sure, several times.
Several times. We're just a little rusty,
Yeah,
that's all.
That's all.
How
Yeah.
many times?
Several.
Well, don't worry about it. It'll come right back to you. It's just like riding a bike. Now, come on, we're wasting precious time.
Hey, where'd you say you learned how to ski?
Kansas,
I didn't know they had slopes there.
Nebraska. Haven't you ever heard of Mount Frosty? And you?
New York
State?
City.
You're kidding.
Haven't you ever heard of Mount Central Park? Oh,
Listen, you don't tell her about my skiing, and I won't tell her about yours.
no. Okay, deal.
Great.
Besides, she'll never notice. Whoa! Whoa!
Oh, no.
Whoa!
Oh, no.
Whoa!
Oh,
What's the matter?
no! The chairlift hasn't even started yet.
Oh, well, guess we gotta go back to the lodge and get some hot chocolate.
Yep.
No.
Come on.
We're gonna stay right here. Stay right here. It'll open soon.
It's a blizzard!
On a clear day?
That's the worst kind!
Clouds. If you want to know what the weather will be, that's what you look for. Can Godot give me a reading on it? Yeah. Yeah, we're holding about 2,000.
The meteorologist in this weather plane took me along to see how they study clouds in their flying workroom.
Get that, Jan? Yeah.
Dr. Dick Darby explained how they work.
What are you doing here?
Taking a weather observation, and we code it up and punch it into the computer, and we send it out to a satellite, which sends it down to the ground in Suitland, Maryland. And they put it on the teletype networks to all the different weather stations. So the forecasters can see what the weather is like out here, because we fly in places they don't have weather stations.
Get that, Jan? Yeah.
How are clouds formed in the first place? This is one thing I've always wanted to know.
You see, first it comes up into the cloud as a gas, a water vapor. Then it condenses into small droplets. That's when you see the cloud. That's the big white fluffy thing, is all these little teeny droplets of water. When they get real heavy, they fall down, and they're heavy enough to fall fast enough so that the air moving up can't push them up anymore, and they fall right through the upward air, and they turn into rain. Right. And if it's cold enough, then it might be snow.
The energy of the sun transforms ocean water into water vapor. This water vapor condenses to form many droplets, visible as clouds. The droplets grow and fall as rain. This rain falls to Earth, where it is captured in streams and rivers. Gravity pulls these rivers downhill until the water flows into the ocean. Here, the cycle begins again.
I've always wanted to know this. What's the difference between a dark cloud and a light cloud?
If you're on the side of the cloud that the sun's shining down, it'll reflect it and make it look bright. Now, if you're on the other side and it's a thin cloud, a lot of light gets through and the cloud will still look bright. But if it's a big cloud with a lot of moisture in it, a lot of water,
It'll be thick.
it's going to be thick, and the light goes through and it diffuses, and it doesn't let as much light through, so it looks very dark.
Guess how the weather plane observes storms? By flying right into the turbulent clouds. Believe me, it got a little tense as the plane was tossed around. When water changes from gas to liquid, energy is released. This energy makes storms. If there is enough energy, then you've got a hurricane. Sometimes these monster storms can be 200 to 400 miles wide. A tornado is a smaller version of a hurricane, but it is still deadly. It's smaller, but more intense. So what are clouds? Clouds are small droplets of water, water changing phase, releasing energy, making our weather.
So did I. Listen, let's go check it out.
Yeah, let's go. Come on, come back. I hold a place for you in mine.
got caught in one of these snow machines.
Is this where you make it?
Nope. All we do here is pump air and water up on the hill. That's where the snow is actually made.
Where that big gun was and it all
Where the
came
big
out
gun
of it?
was.
On the slope that we were on before, how much water would it take to cover it with 1 foot of snow?
About a little over 2,400 gallons an hour, so it'd be over probably about 4 million gallons in a 24-hour
4
period.
million gallons. Wow.
We can cover an area of 12 football fields with a foot of snow in 24 hours.
Is that what you figure out on your computer?
What the computer gives us is the amount of water we push per hour, and same thing with the air. And from there, we can figure it out exactly how much water we push through each gun.
How do you actually make the snow?
The snow is made by mixing air and water through a gun. It's forcing water through a special nozzle that atomizes it in the atmosphere. It makes it into very small droplets, and you shoot it out into the air where it forms little ice crystals as it falls to the ground, as it falls through the air.
So when the air pushes the water out of the gun, as the little tiny droplets hit the cold air, it freezes and turns into snow?
Right.
So it's almost like you're the weather.
The city sweltered today as the humidity climbed to a record 99%.
Whew, it's sticky. You can't see water vapor, but you sure can feel it. Meet a water molecule. Water has 3 phases. When it's vapor, the molecules are bouncing around and moving fast. When it gets cooler, you see water in its liquid phase. Now the molecules get closer together and move more slowly as the temperature drops. When it's really cold, water changes to its solid phase. Every snowflake is different, but each one is 6-sided. The molecules have slowed down so that they lock into this pattern. Snow and ice, water in its solid phase.
Hey! They're starting to lift!
Where does this thing take you?
To the diamond slope!
That's for beginners, right?
No! Expert!
I gotta go back to the lodge. I forgot my goggles.
Yeah, me too! See you later,
Bye.
Robin!
They're on your head! Oh! Wow!
Oh,
Oh, no, Miguel!
I can't believe this. We can't ski.
does this thing make local stops?
No! It's all the way to the top!
How about riding it back down?
That's where the skiing comes in!
Miguel,
Yeah.
do your parents have Blue Cross?
Pure and natural as summer sunlight, cool as a mountain stream. You can pour a glass whenever you want it. No calories, no caffeine. When you're hot and when you're thirsty and your throat is dry, reach for the refreshment that comes to you from the sky.
Careful, it's real slippery.
Whoa, yeah.
Oh, it's icy.
Woo, look at there. Come on. Hey, look.
Hi.
Hi. I thought we were the first ones up here skiing.
Oh, I'm not skiing, I'm working. I came up in this.
Oh, you wrote that.
So we are still the first.
Well, what are you doing up here?
Well, I work for the U.S. Forest Service, and what I'm working on right now is I'm trying to get an idea of how deep the snow is, because I want to get an idea of how much water is right here, right now.
How come you're up here checking the snow and the ice?
It's real important to know how much water is on top of the mountain, because in the springtime, during the spring melts, that way we can estimate how much erosion will happen on this mountain, which is something the Forest Service wants to prevent.
When you say erosion, does that mean all the water would wash away the soil?
Yeah, water acts like a solvent, and it actually dissolves the soil and takes it with it as it goes down the mountain, and it would eventually end up in the stream. And what you'd have here is just a gully with rock.
So we wouldn't be able to ski here anymore, huh?
No, you wouldn't be able to ski here.
You know, it's really not that cold out right now, so why is all this still frozen? And it's not melting.
It takes a lot of energy to melt snow, a lot more energy than what's here today. So it would take quite a bit more of a temperature change before this would melt. As a matter of fact, there's places like in the Rockies or up in Alaska or Greenland that the snow melts so slowly that you actually have what they call glaciers. It's thick ice all year long because there's never enough energy for the snow to completely melt away.
So is a glacier a whole mountain made of just ice?
No, glaciers can be from 1 to 3 miles thick, but underneath all that is land, is the earth, except for like an iceberg, which is a similar type of thing, only it's floating in water. But where they are, like up in the Arctic, it's not warm enough for that ice to melt. And if you think about it, the water around there must be warmer than the ice, but there's not enough energy to make that ice melt. That's the key.
75% of the world's fresh water exist as glaciers and icebergs. Glaciers are moving ice and usually flow about 12 inches per day. Icebergs are fragments of glaciers, always changing, moving, and melting. I've come to Rocky Mountain National Park to make a search. What I'm looking for is the answer to a question. How does a river get started? To find out, I have to go high into the Rocky Mountains, looking for the beginning of the Colorado River. These mountains are the backbone of America. They form the Continental Divide. A drop of water falling on the eastern side of the mountains flows into the Atlantic Ocean, and a drop of water falling on the western side eventually flows into the Pacific. High in the mountain snowfields, Park Ranger Anna Fender shows me how the Colorado River begins.
It starts up in the mountains in the different snowfields and the streams, and they all flow down into the valley and form the river.
And was all that snow, I mean, was it always there, like from the beginning of time?
Some of it's been here since way early last winter when it first started falling. The snow that you're seeing now that's left in the mountains fell last winter. And now it's just beginning to melt and start running into the streams.
How come the snow doesn't melt up there in the summertime when it's warm?
Well, down here in the valley, where we're at now at 8,000 or 9,000 feet, it can be pretty warm in the summertime.
Yeah.
But up at the elevations that you find up there on that ridge and along those mountain peaks, it's 11 or 12 or maybe 13,000 feet. And as you go up in altitude, it gets cooler. The snow accumulates out here in the meadows over the wintertime. And in a meadow like this, the snow can be 6 or 8 feet deep. And then up in the mountains, it can be 20 or 30 feet deep. And then in the springtime, when it warms up, the snow that's down here melts relatively quickly. And the snow that's up in the mountains, where it's cooler, melts slowly.
Oh,
So over the whole summer, it's melting very slowly and keeps feeding into the streams and on into the river and on down.
Oh, like water tanks in the city.
Like a water tank, yeah. It's a storage system for the water. The snow keeps the water up there and lets it out very slowly as it melts. If all of that snow that you see up in the mountains in the springtime were to melt at once, it would just be a rush of water that would come down through the valleys. And then in the fall time, we wouldn't have any water at all.
Does it get freezing cold?
Sometimes. At that elevation, that's where you pick up the beginnings of your streams, the little drips coming off the snow fields, the water running out from under the snow into little rivulets, and then into little streams that come down those valleys. And all those little snow fields up there have little rivulets and streams coming off of them. They come together to form bigger streams that will eventually come on down into this valley and then help form the Colorado River down here in the bottom of the valley.
Now it's a flowing river, rushing to the ocean. Here's the spectacular path the river has cut as it moves downhill towards the Pacific. We call this path the Grand Canyon.
All right. Okay, from here it's downhill all the way.
Robin, how does the snowplow go again?
Are you sure you all been skiing before?
Yes, several times.
Listen, who's gonna go first?
Why don't you go first? And we'll cover your tail in case you get in trouble.
Okay, ready? Come on, let's go.
I use muscles I didn't know I had.
We should do this more often. I feel so healthy.
I'm almost glad I got up so early.
The view coming down the mountain is terrific.
Guys! How many times you say you've been skiing before? Several times! Look at you now! You're so stylish!
Why bother skiing? We have much fun walking.
That was great. Wanna go up one more time?
Whenever there's trouble, we're there on the double. We're the Bloodhound Gang. If you've got the crime, we've got the time. We're the Bloodhound Gang.
Never mind. You get the circus tickets. The show starts in less than an hour. Bloodhound Detective Agency, whenever there's trouble, we're there on the double. Oh, Mr. Bloodhound, thank you for the tickets. Yeah, Vicky's getting them now. Surprise, sir? Keep us on our toes. Have a good flight, Mr. Bloodhound.
We'd better step on it.
That was Mr. Bloodhound calling from the airport.
Something's wrong. The safe won't open.
Let me try.
Did Mr. Bloodhound say he had the combination changed?
That's a surprise.
Goodbye circus, huh?
We'll need a wrecking ball to get at the tickets.
What was that about keeping us on our toes?
Something about training us to work under pressure.
Then he must have left the new combination somewhere here in the office.
Maybe at his desk.
In plain sight for anyone to see.
You just demoted yourself from staff genius. How much time before the circus starts?
48 minutes and 7 seconds.
He'd have left it the last place anyone would think of looking.
Maybe he scrolled the numbers in the dust. Squeaky clean.
Look, he left his ashtray. He must have been using the computer.
You know he quit smoking.
I know a clue when I see one. That ashtray's out of place, right?
Right. Then he stored the new combination in the computer.
Right, and you know how to work that thing. You're promoted back to staff genius. 2 hands, Willie Mates. We're in a hurry.
What is combination? Come here, I got something.
So have I.
Maybe you punched the wrong keys.
Did you find rubber bands? What rubber bands?
These. Look, Mr. Bloodhound drew a pencil line corner to corner, both sides. On the front, he marked stuff above the line. On the back, he drew stuff below the line. He must have coded the combination.
Let me see.
Well, I'll tell the computer we found the rubber bands. Y-E-S.
And tell it we have a bus to catch.
Rotate rubber bands and watch persistence of vision code.
Persistence of vision?
Rotate rubber bands and watch. Got it! The combination! Look, Mr. Bloodhound drew the tops of the numbers on one side and the bottoms on the back. They line up. Spin the card and you can read both sides of the card at the same time.
Left 9. Right 45. Left 30. Right 1.
See, the eye retains the image for a fraction of a second. It's called persistence of vision. I asked the computer.
A couple of wise guys.
The tickets.
Come on, Skip, we've got a circus to catch.
And Mr. Bloodhound did leave a surprise. A bonus. This ought to buy us all the popcorn and peanuts we can eat. 321 Contact is a production of the Children's Television Workshop.